So then what you see in this light wave is the ability to link the nation with just a tremendous information transmitting capability, and to bring information in the form of voice, but more importantly data and video, into homes, into offices, and into factories. Just remarkable technology drive. Do we need all this capability? Well, I submit to you that any new charter which envisions moving from telecommunications to the information age assumes that data and video will be as readily available as voice is today. And that also implies that we need all of the processing, all of the software that goes with that to permit us to manage, to permit us to digest these billions of bits, billions of facts that can be made available almost anywhere. But in addition to that, I think it's very important that we make all these systems easy to use by the untrained operator, like me, the person who can't type. And that in itself implies that we need the friendly communications with machines. And in the ultimate, we want to communicate with machines by voice, not by typewriter. And that kind of communication requires incredibly large processing capability that will gobble up almost anything that we can imagine. So then this technology, this rapidly moving technology, presents a very exciting prospect. But let me return to the original point that got me into this. It is, I believe, this exploding, widely available technology that has forced the change in the technology charter, in the Charter for Telecommunications. So in this sense, it is the technology charter that has driven the legal charter. And also, therefore, the success, the continued success of this new charter depends on the development and the continued deployment of the new technology. Now, turning then to what's at stake in all of this. Now, telecommunications today is already a very large, influential sector of economy and society. And as it reaches out into the information age, it's going to have incredible impact on the economy, in the office, in the factory, in the school, and in the home. And this is only just beginning to happen. And you see we've got a couple of decades of more progress ahead of us. But this is not just a domestic issue. There are others overseas who've embraced this technology and are honing it and become very skilled in this kind of technology. And the effect of that is really twofold. The emergency of technology overseas creates markets for us in telecommunications overseas. But equally, it creates competitors to work into our own markets. And we must bear in mind that today, this nation has the largest telecommunications market in the world. And it's readily open to all comers, including particularly those in Asia and those in Europe. On the other side of this, the global market, which is growing at 8% per year and is estimated to be over 90 billion in about 5 years, is the biggest market for telecommunications that we can see. So I think it's important that we as a nation do well in both arenas, in the domestic market and in the overseas market. For the nation that does well will surely be in a strong position in the world trade, totally. And also I think we have to bear in mind that this isn't just a telecommunications issue, or even an information issue, because beneath it are the related industries of microelectronics, of computer products and computer services. And if you add this in, then the stakes run into the hundreds of billions of dollars and impacts almost all sectors of our industry. So fulfilling this new charter, this technology-driven charter, if you wish, is terribly important to our well-being. Now, what are our stakes? you and me, as engineers or as educators, as industry leaders, as regulators, as members of government. First, I think for those of us in technology, we need to assure the continued reliability and dependability of these kinds of services as they expand. Yeah, it's a sobering thought that in the nation's telecommunications network, with 180 million phones connected by several thousand computer-driven machines, each of which have a reliability of 1,000 times that of a commercial comp center, and capable of setting up 6 million billion connections, but at the control of the average user with a simple keyboard we call the telephone set. That is a standard of service of which we're all proud. And as we go into our new charter, we as engineers, we as technologists, had better be sure that that kind of standard is maintained. Because if the information systems are going to penetrate society, they must do so with usability and with availability and affordability. And what are some of the other demands? Of the regulators, you who are regulators, I would repeat what I said earlier, that we must continue moving towards a level playing field. We must allow the full and fair competition in the parts of the telecommunications business that we as a nation have decided should be competitive. In education, I would only amplify or enhance what Dr. Slaughter had said. We need the knowledgeable, well-trained people to develop and apply this technology. And I think I need not say no more than he has said and other people in this conference and elsewhere has said. And finally, what about the industry leaders and the government leaders? Again, I think we've alluded to that. The most important thing, or one most important thing, is to assure a favorable economic climate in the country. A climate that will encourage the investment in R&D, which inevitably is a long-term payoff enterprise, and the investment in new plants and the investment in new ventures that are absolutely essential to our future prosperity. Let me conclude with a few remarks about my company, about AT&T Bell Laboratories. I'm often asked, when talking about the effects of divestiture, what has this done to Bell Laboratories? What has it done to its role? I'm asked in a very flattering way, will it remain as effective and as valuable as it has been in the past? Well, if you look at the past mission of the company, it has been to serve AT&T and to serve the Bell system by bringing the benefits of technology to the telephone customers in this country. And as a byproduct of that, and just by the way, like any other good industrial lab in a high technology business, we have produced scientific discoveries and technological innovations that have served not only AT&T and the Bell system, but have served the nation. Now, true, we were the largest, and probably still are the largest industrial lab, but we also think we were very effective in that role. But I'll submit to you that we are parallel in that role to any other good industrial lab. Now, is that picture much different post-divestiture? No, it isn't. Bell Labs is still a very large organization. We have 18,000 employees as of today, which is barely below threshold. No, you can't consider that below threshold for an R&D organization. We are a large, healthy industrial lab. Our new mission is to provide the technology to make AT&T a world leader. That's a little different, world leader, but it's part of the trend, I think, that this nation has to go through to compete internationally in information systems and services. And in doing that, we have to be responsive to both the short and the long-term needs. We must help AT&T meet today's market demands. But we must also provide the research that is the basis for technological success in the long term. We must do that because we're in business for the long term. I submit to you that excellent industrial labs, and there are many of them, have served this nation very well. And we at AT&T Bell Labs expect to continue as such a lab to be a major contributor not only to our own business but to the welfare of the nation as a whole. But now let me get back to our conclusions. Yes, the country has a new charter in telecommunications. The stakes are very high. They're very high at home and they're very high overseas. And the continued progress of technology in this country is crucial to being sure that we achieve the most benefit from those stakes. And what we must do is make our traditional combination of our technology and our competitive society work to our best advantage. Thank you.
We have time for some questions. Who picks up the role for providing the research for the local telephone companies now?
We decided, and Judge Green didn't, but we decided that the divested 7 regional companies needed a technical arm to make them good systems engineers and shrewd purchasers of high technology. So we established what was called the Central Services Organization. They have a new name, the Bell Communications Research Company, and we transferred some 3,000 Bell Labs people into that organization January 1 of this year. And they will be responsible for the systems engineering and doing what they can to retain the technical standards within those companies and within the limitations that the divested telephone companies can have because they're not allowed to manufacture, for example. But that's the basic.
Physically in Homedale?
Well, until we can get them out, but until they can find their own quarters, which they're in the process of doing, they are co-located with us, yeah. Not just in Homedale.
Question in back there.
In connection with international competition, it seemed to be the consensus of previous speakers at this meeting that we should continue to take a measured approach toward unilateral gestures by Japan in connection with entering their market. In the face of recent continued unilateral actions, particularly in the telecommunications market, in seeming to lock out foreign competition from Japanese domestic markets, would you take the same attitude, or would you think that perhaps a stronger attitude on the part of the U.S. government toward that behavior should be taken?
Well, I assume your prior speakers were in favor of free trade.
Yes.
And I think I would favor that too. And I don't believe that we should counter an unwise move by any nation by making a similar unwise move ourselves. And we shouldn't give up on the attempt to open up that market. I think that's the right way to go. If we start, and I assume your other speakers have said the same thing, if we start the same kinds of actions, it's just going to domino, and it won't affect just the Japanese-U.S. relationship. It'll spread, I think, to all of world trade. So I think we should avoid that at all possible costs, or avoid it until the most desperate final move.
Other questions? Not? Yes.
What alternative do you suggest to that action?
What alternatives to raising the trade barriers to Japan? Well, I think that we still have to pursue getting into that country. We still have to answer the charges that they make, right or wrong, that we're not good salesmen, we're not aggressive marketeers. We haven't really tried to sell in that country. Now, you know, that you may feel and I may feel this is unjust, but the consequences of going down the other route are so prejudicial that I think we have to hang on somewhat longer. I would have thought, too, that the Japanese, as their economy gets tighter, and as they get off this high that they're now on, may realize that there's some wisdom in keeping a free trade situation in the world. By the way, it's not just the Japanese that are doing this either, as you well know.
Yes.
Do you foresee the Bell Labs getting back into, say, being a competitor in terms of DoD R&D business, as you were, say, in World War II?
Well, we were, of course, in times of national emergency, like any other company, dominated by military work. In the 60s, we had as much as 25% of our activity in government R&D, which strangely was in anti-ballistic missile work. And we got into that, and it's really part of the story I was telling, because it was perceived that as far as guidance and control and electronics, we were the only game around. Now, by the early 70s or late 60s, it was clear we were not the only game around. There was, fortunately, a very strong aerospace industry in this country, and we really had no business in ballistic missiles. We should be in electronics and communications. So we purposely and carefully pulled out of that business. And that brought the kind of government work, level of government work in Bell Labs down to a low of about 3% of our total effort. We're now building that up again, but we're building it up in areas where we have expertise, which is in electronics and communications, command and control. So I guess the answer to your question is that we feel that there is a fair share of the government business in our main line of business that we ought to have, or to aspire for, let's put it that way. And it's bigger than it has been in the recent past, but that's a transition period.
I'd like to ask the audience to show their appreciation of the speakers. The next section will start immediately, and we'll make room for that.
But that's more a folk tale than a good engineering principle, so I won't say it. I won't even know if I'll think it, but we certainly have something good coming. Our previous speakers have discussed technology policy as it relates to the nation, to industry, to our schools. Our next speaker this afternoon will discuss regulatory policy in the medical diagnostic marketplace and how it affects our personal health and well-being. Medical imaging systems have really transformed radiology and diagnosis and allows us to see fantastic things inside our body from measurements taken on the outside. The whole field has been revolutionized in the past 10 years by the microelectronic chip and related technologies and sensing. There probably isn't anybody who's better qualified to give us a sense of the research advances in the field, the marketplace enthusiasm, the medical practitioner acceptance, and the regulatory frustration than our next speaker, who is Dr. Walter Robb. He's Senior Vice President of General Electric and Group Executive for Medical Systems. He can be proud in that they are the leading producers of diagnostic equipment in the world, and I'm sure that each of us if not personally, somebody very close to us will be affected in the next years by what that diagnostic equipment tells radiologists and our physicians. So without further ado, I'd like to present Dr. Robb.
Thank you very much, Dr. Estrin, for inviting me to participate at this 1984 IEEE conference, and certainly to have one paper on technology in healthcare is appropriate, for it's certainly a great time to celebrate the improvements in America's health. You may be surprised to learn that from 1900 through 1981, the life expectancy of a child born in this country has increased by 57%, from 47 years in 1900 to 74 years in 1981. In other words, over this span of 960 months, our life expectancy has increased by 320 months, or 1 month for every 3 months that has passed. A particularly interesting aspect of this lengthening life expectancy is that even over the last decade, the rate of increase has remained constant, even as we get closer and closer to the ultimate biological limit. Now, obviously, there are many factors behind this, such as improved lifestyle, less smoking, smarter physicians, I know my customers, better drugs. But not insignificant has been advanced technology in all kinds of medical electronic equipment. And perhaps even more important than length of life has been the improvement in quality of life that has accompanied this growing span of years. For example, next summer, a number of American companies represented here will be getting together again for a series of athletic competitions to decide the winner of the corporate cup. I even saw you had a 1-mile race here. But in this case, one of the events will be a 10-kilometer run for men over 50 years of age. 30 years ago, even finding 24 businessmen who could run that distance would have been a major challenge, regardless of their age. Today, I suspect they'll run 5, 6, 7-minute miles without even stopping to take a breath. Also encouraging is the fact that modern therapeutic procedures are becoming so much less onerous. Cataract operations, for example, are now being performed practically on an outpatient basis, whereas not too many years ago, a patient had to lie with his head wedged between sandbags for a week or two at a time. Or take the case of angioplasty, where catheters similar to those used to inject iodine contrast material into the blood vessels for an X-ray examination are now equipped with balloon tips that can be inflated to gently reopen occluded arteries, frequently eliminating the need for complex vascular surgery. And while everyone decries the rise in the cost of health care, they also want their sick parents taken care of someplace other than in their home. And the churches and lodges that used to take care of their members in nursing homes are no longer active, and the people are now in public or private nursing homes that now get counted in the cost of medicine. Since 1965, when Medicare was enacted, the number of American citizens 65 years of age and older has risen by 45%, while the general population has increased by only 26%. That alone is going to drive the cost of Medicare up faster than the rise in the GNP. My point is that if we take out the added costs associated with the aging of the population, if we take out the costs of caring for the elderly and the crippled that formerly was performed in the home or church institution, if we take out the well-deserved doubling of salaries for hospital workers over the last 10 years, And you really begin to wonder if perhaps this improved healthcare environment hasn't been the best bargain around. And I believe some of the greatest contributions have come through gains made possible in technology. Unfortunately, I may be addressing the wrong audience, since I suspect almost everyone at this meeting agrees that technology is a good thing. Good for our nation, good for our companies, and good for ourselves as individuals and heads of families. Yet I must also confess that I'm somewhat troubled that our collective views on the benefits of technology are not always shared by the policymakers in this great city. And it's not only in medicine. As a former research scientist, I'm proud and happy that the U.S. has been able to gain a lead in virtually every important area of scientific research there is. But as a businessman, I'm puzzled that our national policies often seem to be designed to thwart a corresponding competitive success in world markets, be it medical equipment, advanced computers, new pharmaceuticals, nuclear reactors, you name it. How tough this government makes the selling of our technology and our technological achievements. Now, I recently saw an item in the local newspaper that the next meeting of the Washington Clairvoyance Society had been canceled due to unforeseen circumstances. Frankly, the crystal ball used by our national leaders may be similarly hazy when it comes to formulating a rational U.S. technological policy. Even worse, federal agencies often seem to work at cross purposes. The Commerce Department, for example, would appear to be the ideal entity to foster and encourage technological developments for commercialization and especially exports. Yet their most aggressive agency is engaged in regulating technology exports, a negative role in danger of being extended rather than reduced. In the field of medical technology, specifically the National Institute of Health seems to place a higher priority on those technologies without much commercial appeal, such as positron emission tomography or dynamic scanned reconstructors, rather than supporting clinical testing in U.S. research hospitals of industry's new prototypes, in which testing is required to gain technical superiority in commercially viable areas. I can assure you that few of our key international competitors suffer from a similar confused federal policy. The Japanese Ministry of International Trade and Industry targets industrial technologies for domestic R&D consortia and protects the home market as an incubator for these developing industries. The British Research Council has an excellent record of helping to fund both CT and magnetic resonance equipment research and is not afraid of tainting academic research by drawing in industrial partners to help commercialize new technologies. And both the West German and Israeli government's own research agencies actively support similar efforts in diagnostic imaging research by both academic research centers and industry. And their home companies are the obvious benefactors. Meanwhile, unfortunately, we continue to sacrifice our technological advantages to sometimes short-term political objectives, such as the embargo on equipment and materials for the Soviet gas pipeline project, or delaying export licenses that allow us to sell our advanced technology products to willing customers in other lands. The really important thing isn't just the business we have lost, but the evidence these examples provide of a disturbing readiness on the part of our leadership to sacrifice technology even further in pursuit of other goals. Forgive me for returning so often to medical equipment examples, but it is the area of my personal business and experience. And in addition, it probably, next to defense, has more to do with our own personal well-being than any other examples I could choose. With that apology, let's concentrate on diagnostic imaging technology, where our nation has had an excellent record. I'm a glass of water, please. We have been responsible in this country for a very high percent of the breakthroughs in this area. And we've seen the recent emergence of modern nuclear medicine, ultrasound, digital X-ray, and most important of all, computed tomography become important businesses for our companies. But even CT, which I think everyone now recognizes as an invaluable diagnostic weapon, had to overcome a storm of official hostility in this country before it could claim its proper role in healthcare. Unfortunately, Washington's crystal ball is still as hazy as ever when it comes to some of the newest innovations in medical technology, now trying to emerge from the research and development laboratory. But since CT neatly capsulizes this conflict between technology and public policy, let me review some of the highlights of this fascinating and instructive story. In 1973, at a time when medical inflationary pressures were only beginning to be felt, a new modality, then called computerized transactional tomography, burst upon the scene. I'll admit, it was first developed by an English company, EMI. But U.S. companies' R&D efforts soon produced the most advanced machines, and even EMI felt